All right, welcome back to Meteorology 101. I mentioned yesterday's video we would cover the models today, so we're going to pull up the surface chart real quick, get an idea where these systems are, where they've moved, and then we're going to shoot over to the models, see how they're initializing, how they're handling these systems, and then pretty much go from there, let the models ride it out. Models are for guidance, they're not for forecasting. A lot of people make that mistake. They take the models for gospel, and that's just not the fact. They change every day. Anytime they do a model run, those models are changing, the systems are changing, and you go any more than 4 or 5 days out, you can pretty much bet those models are going to be way off. So some models get pretty close on the high resolution. In the near cast, the first couple days or so. So a lot of people, the storm chasers, use the HRRR high resolution rapid refresh for storm chasing. So they'll pretty much go by that. They don't use it. They use it for forecasting, not for just guidance. A lot of people. So you gotta be careful with that with the models. That's all they are, is a tool in the toolbox, just to use for guidance. So let's get started. Right now I'm going to go back over to my software. I downloaded the latest data, METAR data. Now I'm going to plot that on the chart, and we are going to let the computer system analyze that for us and find out where our systems are. So just looking at this chart with surface data, nothing else, I can pretty much say there's a system over up to the north. We've seen that low pressure system over just north of Montana. That was that Clipper system going to be pushing through. There was a low pressure system just up to the north over Canada that we had out north of the Great Lakes. That was our main low pressure system. We had that cold front pushing out to the west, and then we had a warm front kind of dropping to the south. So we'll see where that has landed. And then we had that low pressure system developing over the panhandle of Texas. Looks like a little bit of rotation still there. So we'll see if this software picks that low up again. And then we had that high pressure ridging off over the southeast. So we were questioning, was that high pressure going to build and block that low, or was it going to weaken and allow that low pressure to move to the east and continue to develop? We also had the high pressure system with the onshore flow over the northwest. We still have some low ceilings up in British Columbia and Alberta. There's some snow in that area, and we do have IFR conditions. The red, anywhere you see the red, the ceilings are below 1,000 feet. And the red, we're below 3 miles visibility. With the blue, we're below 5 miles visibility, 3 to 5 miles. So it's an and or situation. So with the clouds, 1 to 3,000 feet, and or visibility 1 to 3 miles. So let's pull up the pressure, see where our systems land. So we do have a well-developed low still just to the north over Ontario. And I don't see the surface low over Alberta at this time. We do have a little bit of low ceilings there. The high pressure still have that plateau high over the west. And then we do have the low pressure system over Texas. That was more over the panhandle, which I would push that a little bit back to the west because you can see the winds. We have that southerly wind. We have a northerly wind. You can't have a low pressure system right there. That would have to be the center of that low is pushed back. So this computer is not landing that low perfectly in the center of the rotation of the winds. So sometimes what happens is the computer analyzes 1 hour, and then we get the latest data on these surface plots, and then as that system changes, then the computer doesn't keep up with it. But there's our ridge that was going over the southeast, so that kind of died off a little bit. That weakened, so kind of looks like a possibility for this low pressure system to maybe develop, and the high pressure being out of the way gives it that room to move to the east. But we do have that parent low pressure system to the north that could just be kind of tied in with this low, just kind of a bubble that broke off from that system. So we'll have to see what happens there, and then The high pressure over the plateau, that kind of, I would suspect that should just kind of sit there, and then this low pressure move out of the way. We'll have to see if there's a low pressure system just north of Montana that we seen yesterday, and find out where that is, and we'll look at the models, see how all this develops, just to get a rough idea. Like I said, we don't forecast off the models. You can pretty much use the models, for the average person, just as, hey, is it going to rain? What's the temperature going to be? Stuff like that. Do I need a jacket or not? That would be great for the Weather Channel. Anybody that's dealing with aviation weather, that's the field I came from in the weather field, so I'm way more to the detail with cloud heights, visibility, temperatures, winds, wind direction, speeds, and even pressure. So you got to be able to forecast every parameter with weather, not just is this a low pressure system moving to the east at 15 miles per hour and going to have frontal passage on Friday. I mean, so whatever. Let me throw the fronts on here, just these computer generated fronts, and we'll just see what we have for that real quick, and then we'll get over to the models. Okay, so this is pretty much lost. It has cold air advection to the south, another low just randomly over Illinois, right in the middle of those isobars. Really no rotation to back that up. Warm air advection to the east of that low, but which I would say there might be some warm air advection there, just because we do have a southerly wind. If we throw the isotherms on here, that'll give us an idea if we have any warm air advection in this area. Alright, so wrapping around that low, we do have warm air advection, but you're going to have more of a warm air advection dropping, like a warm front dropping south, not what they have here. So I kind of take that with a grain of salt. This low pressure system, there's really no major isobars around that to indicate warm air advection, or even this cold air advection behind that front. You don't have a low behind a frontal system, a cold front anyway. That's not going to happen. So you have that high pressure and then cold air advection behind that. If you look at these isotherms and then wrapping around these isobars, you'd have some weak cold air advection right there. So maybe bring a cold front out of that low to the west. Warm air advection, like I said, you don't have a whole lot. You got a 5-knot wind coming on shore. That one's offshore. This one's from the southwest with 5 knots. I mean, you just don't have the strength of the wind to move that warm air to the north to bring a real significant warm front out of that low. I mean, if anything, it'd be a very, very weak thermal advection there. So the high pressure, that ridge is weakened and it's moved off. So it's kind of weakened our gradient, and our winds are pretty weak in the south. The southern states there along the Gulf states. So the low pressure to the north, 994 low, that was a pretty weak system yesterday. I think we had over 1,000 millibars. So this thing is deepened significantly. We got that cold front still pushing to the west, which I could probably agree with that, because we have this thermal ridging. Like I said, if you did anything, bring a occlusion out of that, and then bring the cold front. But I think we're pretty safe where we're at with the cold air advection, because these isotherms start becoming parallel with the isobar, so you really don't have thermal advection there. So bring your front to the west. You can see how they're crossing the isobars. Those isotherms are perpendicular in the north, so you do have significant cold air advection in that area. And then the warm air advection, as you're coming out of that low, you do have pretty significant warm air advection in that area, and that's a tight thermal gradient and a tight pressure gradient also. So we do have that pretty strong warm air advection in that area also. So I can kind of agree with that. Alright, so let's get over to the models. And let's see how these systems are going to move. Alright, so we have the low pressure system over Ontario, we have, it looks like that low pressure, this is still picking up that low pressure system in, this is a little bit older data too. So this is 18Z for today. So that's about 1 o'clock this afternoon. So it had that low pressure system over Montana. So that actually dropped south according to the models. We had it up north in Alberta yesterday. Low pressure system in Texas. I'm seeing a little bit of troughing there. Nothing. I don't see a closed isobar to call that a low as far as what these models are picking up. And then the high pressure system, it's got that ridging still off the coast of Florida. It's not ridging over Florida like our current data. So like I said, this is a little bit older data. This is a little bit older data, so we're going to, let's forward that. Let me fix this thing real quick. Okay, so we move this forward. So I guess the initial run on this thing was 18Z. We were valid for, we had 0Z on the second. So that is right now the valid time. But it was ran at 18Z at 1 o'clock. So it was kind of initializing a little bit late, I think. Now that low pressure system over Montana is kind of hanging out. The low pressure system over the Great Lakes is just continuing to move east. That's going to push all that snowfall into the New England states. Looks like Maine. Looks like New York, then Vermont, New Hampshire, and Maine get most of that. You might have a little bit of frozen precip skims Connecticut. That continues to push to the east. The low pressure system over Montana, let's keep an eye on that. Just kind of looks like it kind of drops to the south. It becomes more of a lee side low. High pressure looks like down in the south. I'm going back and forth. It's kind of hard to track what I'm doing here, but going back to the beginning now. We go back forward to the high pressure system over the southeast United States. Kind of just pops up there. Like that bubble breaks off. That's what we were talking about yesterday, with that bubble break off and then block that low over Texas. So I would kind of more agree with that, because if you go back, this isn't even ridging over Florida, so the high pressure is pretty much non-existent. Now it pops up over the panhandle of Florida and into Georgia, and then dies out again, and then it pops up again in the Gulf. So that it's just kind of randomly throwing the high pressure system around. That's why you can't trust these models hour to hour. So what we had yesterday was the ridging all the way to pretty much Louisiana, I believe, and that was a big bubble. We were questioning if that was going to break off. It looks like if you continue with the models here, the high pressure did break off, but there's still a low pressure system dropped to the south in Montana, and then that low pressure of the Great Lakes region moved to the east. So any significant weather is going to be in the northeast for us right now. We got the snowfall out of that low pressure system. That's going to be the warm air advection pushing to the north as the low pushes east, and then that's going to create a stable snowfall for the northeast states and give them probably some accumulation. So let's continue forward. We do have that high pressure system over Utah. Idaho still have the high pressure over the Gulf. The low pressure over Texas kind of just filled in. Now we got the lee side low on the lee side of the mountains in Wyoming right there popping up, and that's pushing to the east. High pressure still maintains in the Gulf. That low pressure looks like it starts to develop over Nebraska, with another low pressure system up in Alberta that is pushing to the southeast also. So now, going back again, we got that low pressure over Nebraska, low pressure to the north of that. The low pressure over Nebraska drops south back into the panhandle over Texas and Oklahoma. And then we have the low pressure system to the north up in Canada continue to push east, southeast into Great Lakes region. Now we have a polar outbreak. Still got the dominating high pressure system in the southeast. We have a polar outbreak in the northeast. That's where we can start seeing a frontal system. If this low pressure system develops, we got the frontal system right here that wraps around that high, and then we can get some significant weather along that front. So that may be developing on these models and then not even pick up the precip associated with that. So it looks like the high pressure system pushes south and then east. Looks like some pretty significant troughing over Oklahoma and Texas. An inverted trough there. Still got this ridging wrapped around that. Like I said, these are tools, not forecasting. You can't forecast right off of these. But we do have a little bit of a disturbance moving through Arkansas. Now we have a low pressure system closed low pop up over South Carolina. Still that high pressure system that dropped to the south moving east. So that drops pretty much southeast, and then we have looks like some isolated scattered rain showers over Oklahoma and Arkansas and Texas. Low pressure in Mexico, another clipper system. Looks like we get out of Alberta, drops into Montana, drops to the east side of the mountains in Wyoming, and then across South Dakota, and then pushes back up to the northeast. Now that might be the next significant system that pushes through. It looks like we're getting a pretty good closed system there with wraparound moisture, snow to the north, and then rain along a cold front right through the central U.S. up into the Ohio Valley. That would be our next clipper system, and that is on the 6th, December 6th. This is valid for Monday, December 6th. So that pushes to the east. Now that's a pretty significant frontal system. High pressure drops well south into Arkansas. We'll see the center of that high. I would suspect that'd be a highly modified high pressure system at that point, but we did get that cold freeze and that cold weather in Texas last year, so this could be a copy of that. Let's go see if this does a. It says click for sounding. Let's go in the center of that low, right up there south of the Panhandle, kind of the center of that high pressure system. Low pressure low. Looks like temperature at that time 37 degrees. So that's pretty cold for Texas. Alright, so if that happens, it's 37 degrees for Texas, and this is December 6th, 15Z. It's 10 a.m., probably 9 a.m. Central on Monday. So Monday morning, waking up a little chilly on that Monday. So, but like I said, this low pressure system will be the one to keep an eye on. The cold front, snow. Back this up a little bit. We get some snow through the Ohio Valley. Freezing precip. That's where it looks like it starts to develop. And then eastern Ohio, southeast Ohio, and western Pennsylvania looks like the heaviest part of that snowfall. Like I said, this is a tool, not a forecast. So way far out on this, 120 hours. Anything past 96 hours, you're pretty much, it's a guessing game. So the high pressure that dropped to the south starts pushing east. That'd be our coldest outbreak. And then we got that low pressure system. It looks like another one that just drops out of the northwest. Kind of becomes a Colorado low, shoots across. That could be a pretty good developing system. But these models have been over-exaggerating those lows constantly when you get this far out. I would like to see a low-pressure system develop there, but I would like to see it develop over the Gulf and then just shoot to the north. That'd give us the snowfall. Probably a lot of power outages, so it's probably usually not a good thing, but I would just like to see that system develop. And then even out of Texas, just give us some a little bit of snowfall, doesn't pick up the moisture off the Gulf, and then that could be pretty good too. But this one actually looks like it's doing pretty good, but it looks like mostly rain, heavy rain, and then some frozen mixed the frozen precip in the mountains, higher elevations. That'll be about it. But that's pretty significant low. 162 hours out. Wednesday, December 8th, Wednesday morning. Pretty much Indiana all the way through Ohio, West Virginia, and then the cold front extending to the southeast and stretching back into, looks like into almost southern Texas. So, like I said, take this with a grain of salt. I wouldn't put money on that for being as far out as it is. And then over the northeast, that looks like some pretty significant weather for the New England states also. Like I said, this is a tool. I don't like it to sit there and say, hey, it's going to rain on Wednesday, because these could change when on the next model run. There's another low pressure system right there out of Texas. That's why I was talking about. If that develops out of Texas, moves to the northeast, you can see that frontal system develop right there, and then that could be something significant to move to the east. That just kind of dies out. So looks like high pressure maintaining the southeast at this point. We had like a clipper system move through over the Great Lakes region. High pressure in Canada, just kind of moving east and dropping southeast. Another low pressure system over Alberta. That could be the next clipper system after that. December 17th, the middle of the month. So I'd say the New England states probably see maybe it's pretty good potential they could see a white Christmas. The other states still iffy at this point. Nobody's gonna make that call. I'd like to see that low pressure system do something and move to the northeast, but you'd have to have a high pressure system drop down behind it, push through, and then bring your freezing level down to get any snow from that system. So, doesn't look like it's going to see that according to these models. But I'm going to zoom this back real fast. You can kind of see these low pressure systems. Guess it's not keeping up with me. Okay, so back to the beginning. Now we'll forward through. Just do a quick loop. We can see these low pressure systems out of Canada moving to the east. You see the high pressure system drop out of Canada. Most of that stuff stays to the north, stays to the southeast, just kind of moves around, lingering around in the southeast, high pressure lingering around in the northwest, and then low pressure just shooting across Canada, the northern states, and then every once in a while seeing one develop out of the south and moving to the northeast. So let's watch this loop. Let me go back. I kind of hesitated when I started, so we're back at the beginning. A little fast. Go back and then forward. A clipper. Frontal system. Pretty significant frontal system then. Then that lee side low dropping off the Rockies and then to the southeast and then moving to the northeast, becoming a significant system for the northeast. Low pressure over Colorado, another low there, and then warm air advection just pushing up around the high pressure system, feeding that warm moist air. Then we get that low pressure system out of Texas starts to develop, and that just kind of dies off. Looks like the high pressure system drops out of Canada and just fills that in. So then high pressure system over the southeast, and then maybe another clipper system to the north. So, all right, that's that. Get back to our charts for a second. So, like I said, this cold front, forget about it. This low, warm front, even that low even being there, just get rid of all this. You got, if anything, with this thermal ridging, bring the an occlusion out, bring the cold air advection, the cold front to the west, and then drop the warm front to the south. That's what I would do with that. So lower ceilings to the north. That front could probably just kind of drop through here, being ahead of that front, being a stable layer, dropping visibility and ceilings over the Great Lakes region. Anytime you get an area that you just look at a chart like this, that has a lot of red and blue, the IFR and marginal VFR conditions. Let me throw that just the station plots back up. You can pretty much say that's you got a stable layer somewhere there that's a stable environment, but a lot of moisture that drops those ceilings, drop those that visibility, and then there's snow, lake effect off of Lake Superior, snow to the north, snow showers. What do we got here? Rain to the south of Michigan, and then, like I said, to the northeast, British Columbia, Alberta. So pretty much all your low ceilings and your frozen precipitation to the north. Looks like rain showers right there through just almost to the coast. So, all right, we're gonna leave it at that, and we'll pull that system tomorrow. I might do a video here later on that, just because with that low pressure system to the north, I'm gonna keep an eye on that. That thing just got pretty intense all of a sudden. So I'd like to go up into the upper levels with this low and see how far up it's reaching. Pull out these fronts, see if we have any upper fronts, how to identify those on the charts, and then see what kind of warm air, moist air, advection we might have in the upper levels to keep this system developing. This low pressure system, like I said, we're rigid over Florida with the high, but the low is just kind of sitting there. It looks like it sits there for maybe a couple days. So you can get some cloud cover. You can actually get some light rain showers. You can get some short, minor shortwave troughs move around this low and just kind of circle that and just sit there until that low fills in and create some cloudy days, on and off rain, stuff like that. So, be more stable than it would be unstable. But alright, I'm going to end the video. I'm going to say thanks for watching and subscribe to the channel. And until next time, get your head in the clouds.